Hey guys, can you believe it? We are at our very last session of chemistry for the year. It has flown by for me. I hope it has flown by for you also. Well, we are going to finish our stoichiometry journey today to talk about one more topic, and that topic today is limiting reactants. So in a chemical reaction, they're just going to keep going until something happens. So for example, and I wish I would have done this, I wish I would have brought a candle. If you light a candle and you put a jar upside down over that lit candle, eventually, what's going to happen? Eventually, the candle's going to go out. Now, why do you think the candle went out? That's a combustion reaction. The candle goes out because it runs out of oxygen if you put a jar on top of it. So that's what we're going to talk about today. We're going to talk about what happens to a chemical reaction when you run out of one of the reactants, because you don't have endless supplies of everything. Like we have endless supplies of oxygen in the air, but we don't have endless supplies of two chemicals, A and B, when we put them together to make AB. So that's what we're going to talk about today. So a chemical reaction stops, like the flame, when you put a jar over the top of it, when you run out of one of your reactants. The reactant that you run out of is called the limiting reactant. So for example, if I have A plus B goes to give AB, and I run out of B, then I can't make any more AB. Once you run out of a reactant, the reaction stops. You don't make any more product. That reactant that you run out of is called the limiting reactant, and it determines how much product you get, because once you run out of it, the reaction stops and you have no more product. The one that you have left over, which in this case is A, that's called the excess reactant. Excess means you have a lot of it. It's what you have left over. So I'm going to do an example for you to show you what a limiting reactant is with a snack. Have y'all ever had crackers and cheese before? Okay, so I've got crackers and I have some little slices of cheese. Now, this is going to be my A and this is going to be my B. When I put them together, I'm going to put one cracker with one cheese. I'm going to get AB. So we're kind of simulating or modeling this reaction that we're doing right here. So if you look at my plate, you see that I've got a bunch of crackers and I've got some slices of cheese. So what I'm going to do is I'm going to put one piece of cheese on every single cracker. So right now I'm basically going through and putting my A with my B and making an AB. But what you find out is that I ran out. I ran out of cheese, okay? I still had 3 crackers left, but I don't have any more cheese left, okay? So in this reaction, the cheese is my limiting reactant. It's the thing that limited the reaction, the thing that you ran out of. My excess reactant are the crackers. I have extra of those, but I can't make any more AB. I can't make any more cheese crackers if I run out of cheese. So that's what we're going to discuss today. How to figure out how much AB you can make when you run out of a certain amount of A or you run out of a certain amount of B, because you can mathematically calculate that amount. So these problems are easy to recognize. So if you were with us the last few weeks, or last week, we did stoichiometry, and you noticed that you were given one number when you started a stoichiometry problem. These limiting reactant problems are going to be a little different because you're actually going to have 2 givens. So you'll have 50 grams of A and 75 grams of B. It'll be 2 values or 2 amounts of 2 reactants that you're given. And that's how you can tell you have a limiting reactant problem instead of just a regular stoichiometry problem. When you have a limiting reactant problem, you just do 2 stoichiometry problems. You work it twice. So these are the steps, because I always like to have my steps written down as I'm going through these problems. Same steps that we've been using, same steps we used for stoichiometry and over the last 5 or 6 weeks. You start with the given, you keep drawing an X and a line until you get to your product. Then you start with given 2, because you're given 2 givens, and you go to the exact same product. Now you're going to compare those two numbers, and let's say reactant A gave you 100 grams of AB, and reactant B gave you 20 grams of AB. You're going to go with the answer that's the smallest. So if I were comparing 100 versus 20, you actually would have created 20 grams of that substance, because when you created 20 grams, you would have run out of that particular reactant. Okay? So let's try one of these. I have the reaction, the balanced reaction, S8 plus 4Cl2 goes to give 4S2Cl2. You combine 200 grams of S8 and 100 grams of Cl2, and you want to know how much S2Cl2 you're going to get. So the step said, you start with a given and you work your stoichiometry problem. So get your handy dandy calculator and get your periodic table, because we're going to start with our given, which is 200.00 grams of S8. You draw an X and a line, and you should know from the last few weeks that at the bottom, you're going to put the unit that you had at the top, which is grams of S8. You also should have learned from last week that the only thing I can put on top of grams of S8 is moles of S8. When you have grams and moles together, one goes with moles, and who remembers where the number for grams comes from? The number from grams comes from the periodic table. So we're going to go over here to the periodic table, and I'm going to look up sulfur, and I see that it's 32.06. So I'm going to put in my calculator, 32.06, but don't forget I have 8 of those. So I'm going to multiply it by 8. And that gives me 256.48. You cross out grams of S8, and you're left with moles of S8. So you're going to draw another X in a line, because we're trying to get to moles of S2Cl2. So we draw another X in a line. You take the unit that it's on the top and you put it on the bottom to cross out. So we're going to put moles of S8 on the bottom, and we're trying to get to grams of S2Cl2. Well, I can't put grams of S2Cl2 over moles of S8. But how can I change chemicals? Go look at those 3 mole ratios that we used last week, and you'll see the only way to change chemicals was to put moles over moles. So on the top, we're going to put moles of S2Cl2. And when you have moles over moles, where do you get those numbers? These numbers were not just 1 and 1, they came from the coefficients. So the number in front of S8 is 1, and the number in front of S2Cl2 is 4. So you cross out moles of S8 and moles of S8, and you're left with moles of S2Cl2, and that's not what you want. You want grams of S2Cl2, so you keep going with the same process. You take moles of S2Cl2, put it on the bottom, and now you can get to exactly what you want. You can put grams of S2Cl2 on the top. One goes with mole, and those numbers come off the periodic table. So S was 32.06 times 2 of those, plus Cl, if you go to the periodic table, is 35.45 times 2, because I have 2 of those, and I get 135.02. Cross out your units, and you see you have what you want. You have grams of S2Cl2. So I'm going to multiply across the top, divide across the bottom, so that's going to give me 200 divided by 256.48 times 4 times 135.02, and that gives me 421.15 grams of S2Cl2. I don't know if that's the answer yet, because remember, that was one given. I have another given. So I have to work a whole nother problem. When you have a limiting reactant problem, you have to work a whole nother problem, but this time you're going to use 100 grams of Cl2, which is your second given. So we're actually going to start with that given. And we're going to go to the exact same thing, because that's what your step said. So I have 100 grams of Cl2, X in a line, and I'm going to go through this one a little quicker. Grams of Cl2 on the bottom. Moles of Cl2 goes on the top. One goes with moles. grams of CO2 comes off the periodic table, and that is 35.45 times 2, which gives us 70.9. Cross out grams in grams. Draw another X in a line because you have moles of CO2. We're going to put moles of CO2 on the bottom, and we're going to put moles of S2 CO2 on the top because I have to take this problem to the exact same unit. I have to take it to grams of S2 CO2. This is a mole-mole ratio, so you go look at your balanced equation. S2 CO2 is 4, and CO2 is also 4. Cross out moles and moles. Draw another X in a line, and you see it's the same ending. On the bottom, I have moles of S2CO2, and on the top, I have grams of S2CO2. You just calculated grams of S2CO2 in the previous problem, and it was 135.02, and moles is 1. So if I have 100 grams of CO2, I'm going to put this in my calculator, 100 divided by 70.9. This 4 and 4, they cross out because they're the same number. And then I'm going to say times 135.02. Now this problem gives me 190.44 grams of S2CO2. So I actually make that bottom one because it's smaller. Because once I made 190.44 grams of S2CO2, I ran out of that reactant. If I'm out of CO2, I can't make any more S2CO2. So I end up making 199.44 grams of S2CO2. So let's talk about a couple other questions that your teacher could ask you here. One of the most common questions, and I think it's on the next slide, but I want to stay on this one so you can see the reaction, is what would the limiting reactant be? Well, I only have two choices. I only have two reactants. So my limiting reactant is either S8 or it's CO2. It's one of these two things. Well, which one gave you the smaller number? Smaller number came from Cl2. So your Cl2 is actually your limiting reactant. Because after you used up 100 grams, you ran out. It's like the cheese. The cheese stands alone. Now, the other question is, what is the excess reactant? What's your other reactant? It's the reactant that you still had plenty of. So your S8 is your excess reactant. Okay? So the limiting reactant is going to be the reactant that gives you the smaller amount of product, and the excess reactant is going to be the reactant that gives you the larger amount of product. So we just answered this. The limiting reactant, let me go back, was Cl2. The excess reactant was S8. Now this is the hardest question that you could get in limiting reactant problems. And it says, how much excess did you have left over after the reaction was completed? So if I'm putting it into a practical sense, it would be like me asking you, how many crackers did you have left over after you made your cheese crackers? Because the crackers were the excess. Okay? So this question gets really wordy, and sometimes it confuses kids. It's just saying, well, find out which thing was extra, which was the S8, and tell me how much of that you had left over. Well, I know, if I go back to the previous problem, that I started with 200 grams of S8. Okay? So I know I didn't use 200, so if you're thinking logically, my answer has to be some number that's less than 200. It's asking you, of that 200, how much was left over? Okay? In order to work that problem, you have to start with some number that you know. We did not use all 200 grams of this. We don't know how much of that we used yet. We know that we did not make 421.15 grams of S2CO2, but I do know that I used 100 grams fully of Cl2, and I do know that I made 190.44 0.44 grams of S2Cl2. So I can choose either of those numbers. I'm going to choose the 100 grams of Cl2 to start with because it's just a nice round number. But you could have just as easily, if you're at home working this problem, I want you to start with the other one. I want you to start with 190.44 grams of S2Cl2, and what you're going to see is that you and I get the exact same answer, okay? So we're going to start this problem with our 100 grams of Cl2. And I'm going to take that. It needs to know how much excess I have left over. Well, in order to know how much excess I have left over, I need to know how much excess did you use, okay? So like how many crackers did you use? If you started with 10 crackers and you used 7, then you had 3 left over. But you don't know how many you left over until you know how many you used. So on the bottom, I'm going to put grams of Cl2, and I'm going to take that to moles of Cl2. 1 goes with moles, and we just did grams of Cl2 a minute ago, and it was 70.9. If you look back at your paper, you've already worked that one. No need to do it again. I'm going to draw another X in a line. At the bottom, I'm going to put moles of Cl2. It's getting kind of low on the board, so I'm having to write a little funny. And on the top, we're going to use our mole-mole ratio, but this time I'm going to go to my excess, and your excess is S8. So I'm going to flip back to the screen before to see what those mole ratios were. In front of S8, I have a 1, and in front of S2Cl2, I have a 4. So in front of S8, I had a 1. In front of S2Cl2, hold on, let me go back. In front of S8, I had a 1. In front of Cl2, I had a 4. So on the bottom, I'm going to put a 4. I'm going to cross out moles of Cl2 and moles of Cl2, and I have moles of S8 left. So I'm going to draw an X on a line, and I'm going to go from moles of S8 to grams of S8. 1 goes with mole. Grams was 32.06 times 8 of them, which was 256.48. I'm going to cross out moles of S8 and moles of S8. And I have grams of S8, which is what I want. How much S8 did I use? So I'm going to put in my calculator. 100 divided by 70.9 divided by 4 times 256.48 gives me 90.44 grams of S8 used. Now that's not my answer, because that's not what the question asked me. The question didn't say how many grams of S8 did you use. It said how many grams of S8 do you have after the reaction was complete. Well, if I started with, let's go back and see how much I started with. I think it was 200 grams. So if I started with 200 grams, and I used 90.44 grams of S8, how do you figure out how much you had left over? All you do is subtract. So I'm going to say 200 minus 90.44, and that's going to tell me that I have 109.56 grams of S8 left over or remaining. Either one will work perfectly fine. If you can do this one, that's as hard as they get, okay? You're working 2 stoichiometry problems at the same time, but you're trying to logically compare them by their amounts to see which one you ran out of first and which one you have left over. I'm very, very sad that this is our last day together, but I'm excited to tell you that we have a question. And I need you to email the answer to this question to mcpsstv.mcpss.com. I'm sorry, at mcpss.com. Let me fix that. mcpsstv@mcpss.com. And your question for chemistry, because this is going to make you eligible for a Chick-fil-A gift card and some other prizes, is what is the name of the chemical that runs out first in a chemical reaction? And I'll give you a hint. It's what the title of today's lesson was. So type that answer in and email it to mcpsstv@mcpss.com so you are eligible for some really good prizes. And again, I'm very, very sad that our journey is ending in chemistry. And I know I speak on behalf of all of our teachers that we really miss you guys. We love you, and that we hope that you have a safe, healthy, and happy summer. Thanks, guys. Be safe.